you have your GDC with you right now?
Yes, sir.
Follow these steps. Okay. Key in the polynomial of moon. Okay, key in the polynomial of moon. And then key in the value of A. After keying in the value of A, if the screen displays the value of Y, value of PA, the value of the remainder will be 0 if x minus A is a factor. But if the value of that remainder is not 0, then x minus A is not a factor. That is what we are saying here. Can you do it now, please? Get your GDC. Let's key in the polynomial of moon. Polynomial of moon is x cubed plus 2x squared plus x. Okay. So we want to find out, so you go to calc, second and calc, rather enter, because you want to find the value of the polynomial. That's why it's a value, so enter. Okay, you can see the graph of the polynomial of moon. And then, there is a blinking light there. Put in the value of A. Okay? Put in the value, let us say 2, and then enter. All right? What do you get? What value of Y do you get? 18. So x minus 2 is not a factor because the remainder is not, the value of Y is not equal to 0. Okay? Key in again. Okay. Go back to calc, please. All right. Enter. Key in another value of x. Let's say positive 1. Enter. What's the value of Y that you get?
4x minus 2.
Huh?
Sir. 4x
What?
minus 18.
Are you with me?
Yes, sir, 18.
When you key in x equals 1, you get 4. So, is x minus 1 a factor?
No.
It is not. Let's go back to calc again. Okay. Enter. Key in now minus 1 there. Negative 1. Not plus 1. Negative 1. Enter.
0.
You get 0. Therefore, x minus 1 or x equals minus 1 is a factor. Rather, x plus 1 is a factor.
Yes.
Okay? Clear, everybody?
Yes.
It's faster than guessing. Okay? Remember, x minus the value of the polynomial at x equals a. Okie dokie? Are you all right? Is everybody okay? You seem so sad. Huh? Why? Oh, sorry. Sorry. Okay, let's go to the next slide. That's a factor theorem. Notice that, look here. if your polynomial can be written as
하지 말아야겠다.
the factor of x minus a times
30 minutes more.
another polynomial of degree n minus 1, okay? And you equate this to 0, all right? Where is that? And you equate the polynomial to 0.
그러니까 zero가
예.
다른 게 팩터라고.
Okay?
y가.
그냥 체크하고 싶어서 미리 집어가지고.
value 그 엔터 누르나. 그래서
예.
그리고 뭔가 이걸 좀 수적기호로 왔는데 이 여기 있으니까 x 마이너스 2
그치, 그리고 그래프 보면 대충 0이 어디 있는지 보이잖아. 그럼 대충 거기
This means that
숫자 근처로 넘어가야 0 되면
x minus a equals 0 or n q of x equals 0. Do you agree?
Yes, sir.
Yes, sir.
Notice, if this is true, what are we saying here? X equals a is a 0 of the polynomial, okay? Or x equals a is a root of the polynomial equation. Clear?
Yes, sir.
네. 네.
Can we now go to the next slide?
Yes, sir.
There's another related theorem related to the factor theorem. There. And this is an extension of the factor theorem. Take a look. Your attention here now, please.
Yes, sir.
If the quantity px minus q is a factor of the polynomial, what does that mean? It means that, let me write it down there. Here. If the quantity px minus q is a factor of the polynomial, okay? And or q of x equals 0, okay? Is this clear to everyone? Alright, now from this equation now, you can solve for x. X here would be equal to q minus p, rather q over p, or x minus q over p equals 0. Okay? So this now can be written as x minus p over q times q of x. That is what we are saying in that slide. This is an extension of the so-called factor theorem. Is it clear, guys? Any questions on this?
No, sir.
Is this clear to you?
Yes.
This portion here?
Yes.
For example, if P and Q are given as, let's say, 3x minus 2 is a factor, okay, of the polynomial Px. So this will be 3x minus 2 times Q of x. You can rewrite that now as what? X minus 2 over 3 times Q of x. Okay, dokie?
Yes.
Everything clear?
Yes.
No confusion? Let's now work out these exercises here. Number 1. Take a look, please. When x cubed minus 2x plus k is divided by x minus 2, the remainder is 5. Find the value of k. Very simple question, which makes use of the remainder theorem. Again, when the cubic polynomial x cubed minus 2x plus k is divided by x minus 2, the remainder is 5. Find the value of k. Any suggestions on how to find the value of k? Come on. The remainder is 5. So how do we find the value of k? What does the remainder theorem say again?
Px divided
Jisoo?
Px divided by x minus a is equal to qx plus a constant remainder pa.
Okay. When we divide a polynomial by x minus 2, okay, the remainder is 5. So what can you say about 5? Para? Again, I'm asking some leading questions in relation to the remainder theorem. You're given your cubic polynomial. You're given your divisor, a linear divisor. When you divide a polynomial by this linear divisor x minus 2, the remainder is 5. What is 5? Other than saying it is the remainder, what is 5? According to the remainder theorem, Joshua?
P of 2.
That's what?
P of 2.
That's the value of the polynomial when x equals 2. You see, that's the value. 5 here is the value of this polynomial when x equals 2. Okay, so the job really is to find the value of the polynomial when x equals 2. Let me see. What is P of 2? Well, this will be equal to 2 cubed minus 2 times 2 plus k. This is the value of the polynomial when x equals 2. Okay? But according to the remainder theorem, this is equal to what? Moon?
It is equal to 5.
Huh? This is equal to the remainder, which is 5. So from this equation, you can solve for k. Alright? I'm running out of blue ink again. Okie dokie, let's solve for k from this equation here. This is 8 minus 4 plus k equals 5. This means k equals what? 4 plus k equals 5. So k equals 1. Right?
Yes, sir.
Okay, here. Number 2. Obtain the remainder. Obtain the remainder when the polynomial px x cubed plus x squared minus x plus 1 is divided by x plus 1. There are two ways of doing this. What? Divide the polynomial by x plus 1, the long method that we illustrated on the board. The other way of doing it is what? How do you find the remainder when you divide that polynomial in number 2 by x plus 1?
We find p minus 1.
Huh?
We find p minus 1, the polynomial p minus 1.
Divide? Divide?
P of minus
And the value of the polynomial when x equals minus 1. In other words, find p of minus 1.
Yes.
And that will be the remainder. What is p of minus 1? p of minus 1 will be what?
답 2 맞아?
This is now number 2. p of minus 1 is minus 1 cubed plus minus 1 squared minus minus 1 plus 1. And how much is this? This is minus 1 plus 1 plus 1 plus 1. And it is equal to 2. Okay? So when you divide this polynomial here by x plus 1, the remainder is 2. You can check it out by dividing it using the long method. Okay? How about number 3? What would be the remainder if the polynomial 3x cubed minus 2x squared plus 7x minus 4 is divided by x minus 1? How do you find the remainder there again, Moon?
Sir, we would try to find p of x when x is equal to 1 first.
Okay, so get the value of the polynomial when x is equal to 1. Right? When x you can do this mentally. When x is equal to 1, this will be 3 minus 2 plus 7 minus 4. See? So 3 minus 2 is 1, plus 7 is 8, minus 4 is 4. You can do it mentally using the remainder theorem, right? Rather than dividing the whole polynomial here by x minus 1. Okay? Let's go to number 3c here. How do you find the remainder when you divide this polynomial by 3x minus 2? What do you do? Let me see, number 3, letter C. The polynomial is 3x cubed minus 2x squared 7x minus 4 divided by 3x minus 2 equals plus a remainder. Which is equal to what? Anybody? The remainder would be equal to the value of the polynomial when x is equal to what? 2 over 3. Okay. So, this is equal to 3 times 2 over 3 cubed minus 2 times 2 over 3 squared plus 7 times 2 over 3 minus 4. There you go. This is your remainder. All right? Everything clear? Questions, please? So I think we have had enough of the remainder theorem. Allah. And the factor theorem. And the extension of the factor theorem. Can we? Is everything clear, Chan?
Yes, sir.
He's still thinking. All right. Oh, another interesting question here. Determine the values of m and n so that the polynomial there, where m and n appear, is exactly divisible by x minus 2 and by x plus 1. Then factor px completely. Oh, this is an interesting question. Let's do it on the board. Can I erase the board, guys? Number 4. You're given the polynomial p as a function of x equals 3x cubed plus mx squared minus 5x plus n. Okay. The words exactly divisible by x minus 2 means when we divide the polynomial by x minus 2, the remainder is 0. Okay? And also, when we divide the same polynomial by x plus 1, the remainder is 0. Okay, how do we find the values of m and n? Sounds like chocolate, huh? M and n. Are you familiar with that? Okay, how do you find the values of m and n? Suggestions?
So using the factor theorem, not the factor, the remainder theorem, we can say that for x minus 2, the root can be equal to 2, x equals 2. So we can say that p of 2 is equal to 0.
That's correct.
And also for p of negative 1 is also equal to 0.
And then we can solve from those two equations, we can solve both m and n. Thank you very much, Moon. Okay, it is given that x minus, the polynomial is exactly divisible by x minus 2, meaning when you divide the polynomial by x minus 2, the remainder is 0. But the remainder is equal to the value of the polynomial when x is equal to 2, right? And this should be 0. Similarly, we divide the same polynomial by x plus 1, the remainder is 0 because it is exactly divisible. Therefore, the value of the polynomial when x is equal to minus 1 must also be equal to 0. So now, we get the value of the polynomial when x equals 2, when x and equate it to 0. So this will be, please follow me, this will be 3 times a plus 4m minus 10 plus n equals 0. Okay? There are two unknowns here, m and n. Chocolate sounding again. So we need another equation. We can get it from here. So this will be, when x is equal to minus 1, this will be 3 times minus 1 plus m. X squared is minus 1 squared, so that's plus 1. M plus 5 plus n. And from these two equations, we can solve for n. Okay, kindly solve for n on your sheets. This is 24 minus 10. 24 minus 10 is 14. Plus 4n. Plus n or 0. What about this? This is minus 3 plus 5 is 2. Plus m plus n equals 0. Okay. Maybe you can subtract this from the first equation. Okay. So if you subtract, what happens? 12 plus 3m equals 0. Right? Are you with me?
Yes, sir.
So what does this mean? M equals minus 4, alright? When m is equal to minus 4, m equals minus m minus 2 equals 4 minus 2 equals 2. Okay? N is equal to minus m minus 2. Minus m is minus 4, but that's positive 4 minus 2. Okay. Questions, please?
Answer.
This kind of a question I saw in the external exam several times. Watch out for that type of a question. Okay?
Yes, sir.
Oh, here, number 5. You can now make use of your GDC to factor polynomial px here instead of guessing. Okay? What do? Key in the polynomial and then go to value, calc, go to calc and then value. Let me see. Polynomial is 2x cubed plus 7x squared plus 7x plus 2. Okie dokie. Let's go to calc, enter value, and then put in the value of x. Okay? If that value of x will give you a 0 value of y, then you know what the factor is. Okay? So I will enter 1. The value of y that I get is not 0, it's 18. So x minus 1 is not a factor. Okay, I'll go again to calc. I'll enter minus 1. I get a 0. So one factor is what? X plus 1. Okay? One factor is x plus 1. There you go. I can write that down now. So 2x cubed plus 7x squared plus 7x plus 2. One factor is x minus 1 or x plus 1. Let's find other factors. What about 2? Is it a factor? Go to calc again. 2. It's not a factor. X minus 2 is not a factor, okay? Or x minus 2 is not a factor. Okay, so let's try. Okay. What about minus 2? Oh, minus 2. It's a 0, so a factor is x plus 2. Huh, guys? Alright. So we need one more factor, by the way. What is it? Let's try, because of the 2 there, take note, there's a 2 there. So maybe another factor would be, let's try 1/2. No. Let's say 3/2, 1.5. No. Okay. At this point, I think it would be easier to get the third factor if we divide this polynomial by the product here. Why don't we try that instead of wasting time on guessing using the GDC? Let us see. This product here is x squared plus 3x plus 2. So let's divide that by x squared plus 3x plus 2 to get the third and last factor. So 2x cubed plus 7x squared plus 7x plus 2 divided by x squared plus 3x plus 2. 2x 6x squared plus 4x 2x cubed plus 6x squared plus 4x, so this is x squared plus 3x plus 2 plus 1. So there's other factor, 2x plus 1. Okay? So that completes the solution. Okay?
Yes, sir.
So from the factors, by the way guys, from the factors, after you have completely factored the polynomial, you can get the zeros. What are the zeros now?
-1.
What are the zeros of this polynomial? In other words, what values of x will make the value of the polynomial equal to 0?
-1.
One of them. Questions, please? Is everything clear, guys?
Yes, sir.
Easy to go to the next slide if there are no questions, guys. Interesting topic. Okay, look at number 1 there. If a polynomial p as a function of x has unique or single factors there, okay, then the graph of px, this is the conclusion here, and the graph of the polynomial will intersect the x-axis at the points x equals a because of that factor, x equals b because of that factor there, because at x equals c because of I heard the door open, because of that factor there, and so on. Okay? So going back to this now, this polynomial when graphed will intersect the x-axis at x equals -1, because -1 is a 0, remember? At x equals -2, okay, because x equals -2 is another 0, and at x equals -1/2. So this polynomial, x minus c, and so on and so forth. That is x minus q squared times dot. Alright? Then the graph of the polynomial is tangent to the x-axis at x equals a. Okay? And intersects the x-axis at the other points b, c, and so on and so forth. Okay?
Yes.
For example, I think we can remove this now. Look at this polynomial. Number 2 here is saying that the graph of this polynomial will cross the x-axis at x equals minus 5. Are you with me? 2 and will be tangent to the x-axis at x equals 3. Okay, that is what we are saying there. Check it out. Use your GDC. Graph this polynomial.
Yes, sir.
See if it is really tangent at x equals 3. That's a 4th-degree polynomial, right? You got the graph? Not yet. You have it? Did you see?
Yes, sir.
That polynomial intersects the x-axis at minus 5, minus 2, and tangent to 3, x equals 3 at tangent to x equals 3.
Yes, sir.
Got it?
Yes.
About this polynomial here, guys. It will cross the x-axis at
3.
x equals 3 and tangent to the x-axis at
X equals
negative 4. Verify it using your GDC. Does your GDC show it?
Yes, sir.
Yeah, very good. Questions, please? Can we move on? How much time do we have?
1 hour.
1 hour.
Oh, we have a
Nonsense.
lot of time.
0.
나 이거 아직 있어 저거?
Every week. Don't. 얘 자꾸 소소해.
Okay? The graph of this polynomial would be tangent to the x-axis at point x equals a, okay? And at the same time, or simultaneously, x equals a is a stationary point of inflection. What does that mean? It means this. Okay. Who? You know how this will look like in the graph, right? What's the graph of this? One, two, three,
그러니까 나는
minus four. One, two, three, four. Okay. So, am I right?
Yes, sir.
Its tangent at x equals minus 4 crosses the x-axis at 3.
Yes.
Okay? Now, wait. For those who are copying, with the graph of qx equals x plus 4 square x minus 3. Okay? What about now if this is, what do you see at x equals minus 4?
Curve.
Very nice, no? Yeah.
변곡점.
To be, I will use, no, I will not use a red.
변곡점 영어로 뭐지? 컨캐비티.
Cavity.
올라가니까
Cavity is
내려가니까.
It changes
변곡점이 따로 영어로 term이 있지 않을까?
전국점이 그거 아니야?
Here.
그럼 inflection point.
그거는 아까 니네들이 말했던 그 충치는
1, 2, 3.
그러니까 뭐
Minus 1, minus 2, minus 3, minus 4. Okay, here is what happens at x equals minus 4. Because of the cube there. Okay? Polynomial graph will look something like this. Alright?
Yes, sir.
Now what happens here at x equals negative 4? Two things happen. One, tangent. Two, the graph changes concavity. There are two types of concavity, by the way. This is
concave up.
concave down. This is concave up. Alright? Notice that here, from here up to that point, the graph is concave up. But from the same point to somewhere here, the graph is concave down. Therefore, at that point, the graph changes concavity. And therefore, we say that at that point, the graph has a point of inflection. In this case, that point of inflection is called a stationary point of inflection. Stationary point of inflection or horizontal point of inflection. My voice is getting terrible. Okay? So, x equals minus 4 is a stationary or horizontal point of inflection. Why do we call it horizontal point of inflection? Because at that same point, the tangent to the graph is horizontal. Clear?
Yes, sir.
Questions? So you can see the difference, please. There's another type of horizontal point of inflection. Take a look. Here. Ay, nako. There. Look at this. From here up to that point, it's right here. Again, listen to me. From this point going to the right, the graph is concave down.
Yes.
All right?
Yes, sir.
Look at my hand. From this point going to the right, the graph is concave down.
Yes.
But from somewhere here up to there, the graph is concave up. Therefore, somewhere between this and that, there is a point of inflection. Say there. This point of inflection is simply called a point of inflection or a non-stationary point of inflection as against this stationary point of inflection. Why do we call this non-stationary? Because the tangent to the graph at that point is not horizontal. Clear? And also somewhere, or no more, because it's already concave up all the way up to positive infinity. But listen to me, if this graph now goes this way, whoop, so somewhere between this point and that point, okay,
Done.
so what do you call again this value x equals horizontal tangent? Agreed?
Yes, sir.
And at the same point, the graph changes concavity, either from being concave up to concave down, or from concave down to concave up. Clear?
Yes, sir.
Okay. Let's see now. Can you get the factors here using your GDC? You see, if you can factor this and the factors are 4 distinct, then you expect the graph of this polynomial to cross the x-axis at 4 points. But if some factors are the same, all right, can you work on it now? Let's use our GDC. X to the 4th minus 8x squared plus 18x minus 9. X to the 4th minus 2x cubed minus 8x squared plus 18x minus 9. Okay, very good.
이거 어떻게 두드리는지
Adjust your
알려주세요.
window.
어떻게 두드렸죠?
그래 나서
And then from the graph, actually, no? From the graph, you can already get the factors.
마이너스 8x
What do you see from the graph?
플러스 18x
1, 0 is negative 3. Guys, are you with me? I am now trying to get the factors
땡큐.
using the graph of the GDC. And what does the graph look like?
X가 어디 있는 거야 혹시?
My GDC says, where is my marker? This is number 1. One, two, three. There's the graph, more or less. Okay? So what do you think should be the factors now of that polynomial Px? One factor is x plus 3. The other factor is x minus 3. And the other factor is, right? So if you can get the graph using your GDC, how about number 2? Can you work on number 2? Oh, degree 5. That's terrible.
그 축소는 시키지.
Can we graph number
아 축소 같은
2?
거못 시키지.
Guys, but before we do that, please allow me to go to the CR. Kindly graph number 2 on your GDC and tell me the factors, please.
Yes, sir.
아, 50, 50이 된 거야? 땡큐. 유레카.
Do you understand?
What? the polynomial functions. Wait, not this one. The one before one. Like the, what do we call it? Remainder theorem? That one.
Remainder theorem. The only thing you need to know is, you know zero or root, right?
Yeah.
Root means it intersects x-axis because y equals 0. So every point on the x-axis that is intersecting, like example here, right?
This is a root minus a root and some root. That means f of x when it is at minus 4 is equal to 0. Because y value is 0, right?
Can't do that.
Maybe.
Maybe.
Ah.
Just try to look at the formula again, maybe. If you...
Should you understand? Can we just use the GDC? Should you understand?
Yeah. And then basically if there's an put in the equation x minus number. So x minus 4, x minus minus 4, then x plus 4. Then that's a factor. That's all we need to know. Sir just makes it long.
아.
근데 내가 발이
Oh,
예쁘진
sir's
않긴 해.
휴대폰.
어,
마마마.
Oh,
합하면 씨발. What is most
Oh, YouTube.
Catch the war.
What's that?